Hello and welcome back, my dear students. I hope you guys have understood the previous video on functions very well, because like I mentioned in the previous video, today is a continuation of the previous video. So today we'll be talking briefly about the three ways in which we can present the domain and range. So the first one is inequality notation, and then we have set builder notation, and we have interval notation. Now, I thought to explain all of these three with an example. So I just took one example. So we have the function. So let me write this in the function form. So you have f of x is equal to the square root of course we're talking about the fact I'm taking the positive side, square root of x minus 1. Okay, now something which we all should already know by now is that whenever you see a square root, guys, or an even root, I would say, what is something which we need to consider? That is that the radicand means the value inside. In this case, this is x minus 1, cannot be negative. It can be 0 and above to give us answers or to give us outputs. So in other words, what I'm trying to say is that x minus 1 should be greater than or equal to 0. It cannot be less than 0. So let's see what x values qualify to be the inputs of this function. So if I solve this inequality, I get x is greater than equal to 0. I'm sorry, x is greater than equal to 1, I'm sorry. Okay, so we know that x can start from 1 and move all the way above, but it cannot go below 1. For example, if you try to put x as 0, so we get 0 minus 1, which is negative 1. We know that this is an even radical, and it cannot have a solution if we have a negative value inside. Even if you take a value less than 0, it's going to go more towards the negative side, right? So we cannot take x as something less than 1. It can be 1 minimum and above. Now let's come to how do I present these things in three different forms. I know that the value of the domain here is x is greater than equal to 1. So let's look at the inequality notation. If I write it in the inequality notation, okay, I'm going to write it as x is greater than or equal to 1. Okay, of course no one has the only task to write all the values separately. Okay, we will lose all our lives, so that's why we have something known as inequality notation. This tells us that x can be 1 and all the values above 1. Okay, now let's come to the set builder notation. In the set builder notation, what you do is you make the braces, you write the variable x, you make a vertical line. This vertical line means such that, okay, now we're talking about all values greater than equal to 1, right? So you can just simply write x is greater than equal to 1. Okay, this is known as set builder notation. And then we have the interval notation. Now the interval notation uses brackets or square brackets to represent the endpoints. What do I mean by the endpoints? So let's look at this domain. We know that x is greater than equal to 1. Means the domain starts at 1 and ends at infinity, right? It will never stop. So the way we write it is, if a 1 is included, means the minimum point is included, we make a square bracket. Keep that in mind, very important. So 1 all the way up to infinity. Now whenever in mathematics you have a interval, it ends with infinity, right? It has infinity on any side. You always use a bracket like this. It will never have a square bracket. I hope this part is clear. Now let's look at this function y is equal to square root of x minus 1. I have already plotted some points here. You know that if you substitute x as 1, you get y as 0. So there you go. And then if you plot x as 2, you get square root of 2 minus 1, which is 1. And then there you go. At 2, you have 1, right? And so on. So definitely this is going to be a curve. And I'm talking about the positive side. Okay, that's why I wrote y is equal to positive square root of x minus 1. Now guys, what about the range of this function? You know that the range begins at y is equal to 0, and then it's gonna, this will eventually keep on increasing, and it will never ever stop, okay? Unless we stop it. So the range can be written as y is greater than equal to 1. I'm sorry, y is greater than equal to 0. I'm sorry. Okay. Now you can even write it similarly in the set builder notation, and you can write it in the interval notation. Okay. So this is it for today's short lesson, and I hope to see you guys in the next lesson. You guys can always email me at prof_mahat@hotmail.com for any questions, for any online sessions, for any in-person sessions. Thank you so very much, guys, and you guys take care.